Okay, I'm going to do an example problem here of analog to digital conversion where I'm looking at CD quality sound, 2 channels for stereo, and the standard for creating CDs is 16 bits of sampling depth and an actual sampling rate of 44.1 kilohertz. For the very first part of this problem, I'm going to assume a high frequency of 22 kilohertz, and we're going to start off calculating the Nyquist sampling rate. Our Nyquist is twice the highest frequency. And roughly speaking, if this is a sine wave of the highest frequency, you'll notice that it takes 2 samples per cycle in order to capture the up and down. And that's why we have the Nyquist sampling rate at twice the highest frequency. Okay? There's 2 samples per period. In any case, if the highest frequency is 22 kilohertz, then our Nyquist sampling rate is 44 kilosamples per second, or just 44 kilohertz. And now the actual sampling rate is 44.1, and we're going to use that for the rest of the problem. Now I'm going to calculate the data rate for one channel. The bit rate is equal to the sampling rate. So my actual sampling rate is going to be 44.1 kilohertz, or kilosamples per second. The bit rate is the sampling rate times the bit depth of the sampling. And 16 is our bit depth, bits per sample. Okay, gives 2 to the 16th different voltage levels. And so RS is 44.1 kilohertz, and NB is 16 bits per sample. And 44.1 times 16, let's see if I can calculate it. 44.1 times 16 is 705.6. And this is going to be kilobits per second, or 0.7056 megabits per second. Okay? And if we want to calculate the bit rate for stereo, it's just twice the bit rate for mono. So this is mono. And if we double that, 2 times 0.7056, we get 7056 doubled is 0.0056 doubled is 0.012. 7056. If it were just 0.706, it would be 1.4. Let me think for a second here. 0.7056, 0.7056. I don't want to get it wrong. 12, 11, 1, 4, 1. 4112. Yeah, I thought I was doing something wrong here. 4112. Okay. And this is going to be megabits per second. Finally, 4 minutes and 16 seconds is T, and it's 4 times 60 plus 16, which is 240, plus 16, which is 256 seconds. So the total number of bits is the bit rate times the time. And it is 1.4112 megabits per second times 256 seconds. And let's see, if I multiply those out on the calculator, I'm going to take 0.705 times 2, 1.4112, right? And now I'm going to multiply by 256. And I'm going to get 361267. Three, 6, 1, 2, 6, 7. And this is megabits. And I'm going to divide this to get by 8 to get megabytes. And I get 45.16 megabytes. It's 361.267. 256 times 1.4 is 361.267 megabits. And divide that by 8 to get 45.16 megabytes for one song, which is typical of a WAV file. Typical WAV file sounds is about, for a song, is 40 or 50 megabytes. Okay, hope this helps and is interesting to understand how CD quality sound works.